Hey everyone, welcome back to our second video on creating accessible toys for blind children. If you haven't checked out our first video, it went over creating a base duck toy project that will have Braille labels on it attached later. This will allow blind children to be able to learn through touch early on in their lives. The first video in our series showed you how to make the base body of the duck. Now we'll be adding some of the details and the Braille labels that actually make this project functional. So let's get started. The details we are going to be adding to our duck project are the eyes, the bill, the nostrils, the feet, and we're going to add some water to the base of the duck to make sure it has a strong base when 3D printed. If the duck isn't your base project, skip on to later in the video to learn how to add comprehensible Braille labels to your project and make it actually functional. Okay, so to start off making the eyes of our duck, we're going to pull 3 spheres into the project scape. After pulling your 3 spheres to the work plane, one of them is going to serve as the outer casing of your eye, so basically the eyelid of the duck. You're going to want to move that sphere up to where you want the eye to be on the head and make it a little bit smaller as well. After sizing your sphere the way you want it to be, you can click on it, click Command C and Command V or whatever actually duplicates on your computer. You're going to want to move it back into the same spot as the original sphere, and then click the mirroring tool and mirror it on the x-axis. And what this will do is once you move it over using Shift, it'll give you the exact same shape on the other side of the duck's head. After duplicating your duck's eyes, you might need to spend a little bit of time adjusting the breadth of the eyes and how far they come out of the head just to make sure that your project looks natural, and do this based off of your own instincts. After doing this, you're going to want to take another sphere and you're just going to size it to be a little bit smaller than the sphere you used before. So just move it up back to that eye, and you're going to want it to kind of carve out a little section of that sphere. When you position this inner pupil of the eye, you're going to want to make a crescent shape out of the sphere we had before. So if you see and you change the colors here, you'll see this crescent shape, and that's kind of how a duck's eye naturally looks. It has a crescent shape that kind of acts as the eyelid for us, and then we're going to make this sphere a hole, so we're going to kind of cut out a socket for which the pupil of the duck's eye can actually fit into. So quickly you're going to click your sphere that you were working with, make it into a hole, and group it with the eye socket that you were working with before. Then you're going to want to take your third sphere and you're going to make it a little bit smaller than the hole we just cut out of the eye socket. And this is going to fit in and be the darkest part of the duck's eye, so the inner center pupil that actually lets the duck see. You're going to want to recreate this on the other side of your duck's face. You can do this by just duplicating the eye you've just made, or you can recarve out the eyelid and redesign just as we did before. If you are copy and pasting the eyeball, what you can do is you can just use Command C and Command V or whatever your hotkeys are and duplicate that object. Then you're going to want to move it back to its exact original spot, so where we copy and pasted it out of, and then you can use this thing called the mirror tool, and you can choose the axis you want to mirror it on. It's probably going to be the x-axis, and then we're just going to shift click and move it over to the other side of our duck's face, so it should look just about the exact same on the other side of the duck's face. Also, if you want your eyes to be aligned on both sides of the duck's face, you can shift click on both of them, use the align tool, and actually align them to a central axis. Once doing that, your duck's eyes should be just about finished. If you want to ungroup the shapes you were just working with and make them different colors, it could make your 3D model look a bit more realistic, but when you actually print this duck, it'll all be the same color because we're generally going to use the same filament, so it doesn't make that much of a difference. So after finishing the eyes, we're going to work on the bill of the beak. So we're going to make it look more natural, like a real duck would look like. So if we're to look at a duck here, you can see there's a conic shape towards the beginning of the beak, and then it flattens out to this flat surface. So the way we're going to recreate that in TinkerCAD is, you've already got this conic shape here, and from last time we actually increased the amount of sides the cone has, because by having less faces it looks like a more natural and smooth shape. And then to make this flat part of the beak, we're going to just first drag over a rectangle to our work plane. What you're going to want to do is you're going to decrease the rectangle's height to about 2 millimeters. And then we're going to play with the length and width depending on how it will look on the duck in the final product. So we're definitely going to have to change these dimensions, but as a starting dimension, let's start with about 6 millimeters or 6.5 millimeters wide. And in terms of length, I think we should go for about like 16 or 14 millimeters. So 6 millimeters wide and 14 millimeters in length. And then to actually give that curvature to the beak, because if we look at this duck here, it's not, these flat parts don't have corners on them. They're very curved. And so to do that here in TinkerCAD, we're going to go to the radius. Once you click on the box, if you go to radius and you increase that, it'll start to curve these edges of our object. And so I'm going to go for about around 4 millimeters of radius for that curve. So once you're at this step, you're actually going to have to angle the bill of the beak to match the angle of the central axis of this cone. And in order to do that, we're just going to kind of type in our angle here. So we can type in an angle of about, I don't think it'd be 22.5 degrees. That's a little bit too harsh, but maybe we could do an angle of like 12.5 degrees. And you can keep playing with that angle and keep resizing your beak until you think it looks natural. And just another tip, if you were to resize your bill with these white squares on the side, it would kind of change the angle of your actual flat part of the beak. And so in order to kind of avoid that, we're going to use the length and width scrollers right here. So these keep it at the same exact angle, but allow us to change the dimensions of our project. All right, so after you're done tinkering with your bill, you can actually align all of these objects. So you want to align the cone, the bill of the beak, and then also the head in one straight line, right? And you can use the align tool to do this. So you click on all the objects, you don't group them together, but you shift click on all the objects you're trying to align, and then click on the object that you want to align them to. So I want the beak to be aligned with the center of the head, and I'm just gonna click on this central part, and mine was already aligned. And this is gonna make your beak aligned to the center of the head. All right, so I think my beak is looking pretty good, so we're just gonna make it the same color so it blends in with the rest of the beak. And now we're gonna add these melanin spots to the inner parts of our beak. So if you see here, these kind of look like nostrils on a duck, but they're actually spots or parts of melanin in the duck's beak, and we're just going to recreate those here by using a sphere. All right, so for these melanin spots, we're just going to take this sphere here and move it up towards the beak. Then we're going to want to make it a lot smaller so that it fits in the nook between this cone and the bill of the beak we designed. After making one nostril, what we're going to do is we're just going to Command C and Command V that, so duplicate it, move our object back into the exact same spot, and then we can just mirror our design on the X-axis and then move it over with our arrow keys to the other side of the duck's beak. So those will be perfectly symmetrical. And then to align both of these nostrils, we're just going to shift click on both of them, use our align tool again, click on one of them, and then just try to align it to the center there. All right, so after finishing the duck's beak, we're going to move on to the feet of the duck. And to do this, we're going to just first drag a simple cylinder to our work plane. Now we're going to make the cylinder a lot thinner, and it's going to serve as one of the central 3 axes of our duck's foot. Then we're going to turn it 90 degrees and move it to the floor of our workspace. So this can serve as the central axis of our duck's webbed feet, and then we're going to have to copy and paste it a few times, so 2 more times, to make the other 2 parts of the duck foot. Do is use the angle editing tools in TinkerCAD to actually make the triangular shape of our webbed foot. All right, so after making the 3 main poles of our duck's foot, we're just going to fill in that extra space, and we're going to do this with the squiggle tool. So basically, we're going to drag the squiggle tool to our work plane and then draw in what we want to cover up the rest of the duck's foot. Now, this doesn't have to be super beautiful or anything, but basically, TinkerCAD is going to make our drawing into a 2D design, and we're just going to need to reshape it into the creases between the duck's foot. Now in this case, I've drawn a lot more than I needed to actually cover the duck's foot, so I'm just going to double click on my drawing and delete all of the extra stuff I don't need. Alright, so after you finished editing your drawing and filling in all of the parts of the duck's foot that you want to, you can just change it to the same color of the duck's foot, and we might need to edit the lengths of some of these parts, but yeah, then we've got the perfect webbed foot for our duck. I would group together the parts of the duck's foot, so the squiggle and all of these rods here, and I would group them together, and then we can just Command C and Command V this part, then we can mirror it on the x-axis and then just move it to our other foot. The last thing we need to do is we need to create some sort of water. And the reason we're going to make a base of water on this duck is it's going to give a lot more surface area for the duck to stand on when it's actually 3D printed. Now you don't have to do this, but when the duck is 3D printed, if it only stands on the 2 feet we've made it here, it would likely tip over or just be unstable generally. So we're going to add that 2D plane, or still 3D, but flat 3D plane to the bottom of the bird's foot and disguise it as some sort of water to give this 3D print or this statue that you might make a little bit more balanced. Alright, so that finishes up the details of our duck, and now we're going to move on to the most important part of our project, which is adding those labels with Braille inscriptions on them to kind of label, oh, this is an eye, this is the bill of the duck, this is the foot of the duck, this is some water, and have blind children actually be able to touch these features, understand what they're made up of, how they look, and then also touch the Braille inscriptions to connect words to actual features. For this project, we're going to be using grade 2 Braille, and there's generally 3 levels of Braille that are used in public projects. Grade 1 of Braille is just using letters and putting them in sequences to make words. And grade 2 of Braille is pretty similar. Now there's some conjuncting words like and, so, but, that you can do with just a few dots. And then grade 3 of Braille turns entire words into dots, but the most common type of Braille used in public projects is grade 2 Braille, and so that's what we're going to be using for this project, but it doesn't really differ from grade 1 Braille in this scenario because we're not really using that many conjuncting words. Alright, so for the Braille labels, the first step is going to be to add these flat surfaces next to the features you want to label. I've kind of skipped ahead here, but all you need to do is drag a cube to the work plane, resize it to the size you want your label to be, and then move it over to whatever feature that you want to label on the duck. So some of the important features I've labeled here is the webbed feet, the wings, the overall body of the duck, the neck, the eye, and the bill. Now, Braille is generally written with something called a Braille slate. And so Braille slates kind of allow you to format where your letters will be and the spacing between them and the spacing between the dots. So we're going to upload a Braille slate from another 3D design from Thingiverse, and we're going to bring it here to label the rest of our features. Now, sometimes these labels will likely need to be a little bit bigger, especially because for children to feel these and actually interact with the project, generally it's better to have bigger font, but Braille is just generally written in bigger font. So you might need to make some of these labels bigger than I've shown here once you actually start writing, and that just takes some adaptation later on in the project. Alright, so we're just going to head over to thingiverse.com, and if you search up Braille slate, a bunch of amazing options should come up. We're just going to use the one-line one because we're just going to be writing short labels on one line. And so this is by Cryene, and this is, made in 2019, but it's an amazing way to write Braille with that standardized spacing between things. So we're just going to go down here to their 3D design and just download that file. Now, to use their design in TinkerCAD, we're going to need to go to the import menu and import the file. Alright, so once you've imported this file, you can definitely resize it. It's just important to pay attention to how big your Braille will actually be. You don't want it to be too big or too small because, it needs to fit with the sizing of the project, but also you don't want your project to be too big that it's not 3D printable. And you don't want your Braille to be too small that children can't actually decipher what the project is saying. So I'll show you how to go about making the first label on this project, and you can go ahead and finish the rest in your own time. Alright, so after lining up your label and your Braille slate, you can now drag and drop cylinders into the different slots of the Braille slate to actually create the words you're trying to create. So in this case, we would create the word foot. Alright, so after you've made your cylinder fit into the slot the Braille slate has provided, we're going to need to figure out what letters we actually need to write in Braille. And this is pretty simple. You can just search up a Braille translation system, or you can just search up a chart for what dots equal which letter in Braille, and we can work off of that. Alright, so now we've got this amazing chart by the Canada Science and Technology Museum, and we can just use this to figure out what letters equal what dots and what we're actually going to write on this duck. So in our case, we're just going to write the word foot, so we just need F, O, O, and T. And so to do that, we're just going to copy and paste our cylinder into the right slots of the Braille slate to write the correct letters. And one thing I'd make sure to do is make your labels a little bit bigger. It just makes it easier to translate and read your project. And so the final thing you need to do is just continue to translate the different labels you want to make onto your project, and our project would be done from there once you finish all of the labels you've created. In terms of efficiency, you might want to move all of your labels to the floor of the work plane and just continuously use the Braille slate and make all of those labels first and then move them over to the project. But what you want to be careful of when doing this is that when you're moving your label, you don't want to accidentally stretch it out or change the angle so that the Braille is undecipherable for a young blind child to actually translate. Alright, so thank you so much for watching. Hopefully you enjoyed making this project and want to make some of your own animals to apply this Braille lettering system to. And we are excited to come back with more projects in the upcoming weeks. If you want to volunteer with CAD Thinkers, help us make some of these YouTube videos, or actually teach some students in person and develop curriculum, feel free to go to www.cadthinkers.com, and you'll be able to volunteer and sign up for different sessions and opportunities on there.